because gravity is what they call one of the 4 fundamental forces in the whole universe. Okay, and so I'm gonna list them in their order of their strongest. So like this would be your number 1. It's called strong nuclear force, a strong force. That is the pull of the electron in with the proton. That is just like super strong. It could even be what the protons and stuff are made up of. The next one would be, let me see, probably electromagnetism. That is the pull of one molecule to another. That's a pretty strong one. Weak force, that I can't remember off the top of my head, but that's probably the next weakest. And then the weakest of them all is gravity. Okay? Weakest of them all is gravity. The weakest of them all is gravity. Now, like I said, you all understand it. You know what the effects feel like. We don't know exactly what causes gravity. It is a mystery of mysteries. They think that there could be a particle that we haven't discovered yet because it's so small and so light. And they gave it a name. They call it a graviton. And they think that the particle of a graviton carries gravity. But we don't know. We haven't found it yet. Maybe one day we'll find it. That's just one of the many theories. Now you know that gravity, and maybe you don't, but you need to write it down. It relies on mass for its strength. The more massive something is, the more gravity it's going to have. You guys ever heard of a black hole? In the center of a black hole. Now I want you to look. Look, well, matter of fact, see what I'm doing up here? Watch this. Can you see that dot that I drew? I'm trying to draw like think of a grain of sand. They think at the center of a black hole, there is an old dead star that couldn't keep itself pulled out, because stars are always exploding. They want to explode, but gravity pulls them back in. But when they run out of energy, there's nothing keeping them pushed out. So they go in like less than a second, boom, they collapse. And it's so strong that light can't even escape it. Light that travels 286,000 miles per second, or 186,000 miles per second, it can't even escape it. So black holes, they look like holes because light goes into them. And once you get caught, you're in. Okay, so that's the most massive thing we know about. The sun is a massive object, but not like that. It's not strong enough to bend light. It still gives off light. Think about it. The sun is exploding all the time, but its mass, it's wanting to pull it back in and just keep pushing out. But eventually the sun is going to run out of energy. But since it's not like this really big supermassive star, when it collapses, it's going to go in like a fraction of a second. And if this was, and I'll show you a picture, if that was Earth, they probably are like that when they're done. Okay, now that's pretty intense gravity, but still not enough. Now, not only mass, but distance. Think about it. The farther you're away from the sun, gravity gets weaker and weaker and weaker. And if you get, whenever you talk about gravity, you got to think, oh, it's got to do with how massive it is and how close it is to you. I've seen horror movies where a planet, matter of fact, the moon was actually formed like this, where a body about the size of Mars slammed into the Earth just at the right angle, the right speed, and kicked out the moon. Kicked out the moon. The gravity made it form into a ball. Now we have a moon, which was very, very fortunate we have it, because the moon allows the planet Earth to only tilt like this. If this is north and south, and it'll tilt 23 degrees this way exactly, 23 degrees this way. And so winter, summer, winter, and it just does this. And because of that, we got predictable weather. We can grow stuff thanks to the moon. If it wasn't there, Earth would do this. It would lay down on its face, and it would go back, and then it might go back here while it's spinning. It's going to go uncontrollable. So the moon gives us that nice little gravitational, hey, hold on. And so it does that. And so you need to know that gravity, characteristic of all matter. So if we were to ride in my special Chevy truck, we go up to outer space, we all get out, we got our suits on, and we all huddle, like 1 foot away from each other. Well, aren't we massive? Yeah, we have mass. So over time, what's going to happen is we're all going to, if we don't move, just sit there, we're all going to suck in together because we're attracting each other because of gravity. And so the bigger the object, the more massive it is, the more stuff is packed in it, the more mass it has. Attracting force between two bodies, objects don't need to come in contact. A lot of people think that tonight's a full moon and crime goes up during full moon. We don't know what it is about the full moon. Some people, the moon is actually pretty close to us right now, so the gravity is really strong. You guys have heard of tides, right? It would actually, the water gets pulled up into a wall, and it depends on where you're at. It could be 8 feet, but it comes in so slow, it doesn't hurt anybody. So if you live on the coast, you understand tides. Not so much here in Indiana, not on the Iroquois, even though it is acting in there. Okay, and so there's what we're always thought about gravity. Right in the center, you got the sun. The sun is constantly holding everything here. But what are these doing? What are all the planets doing? Help me out. Are they just sitting there? What are they doing? They're rotating, but they're also, what do you call it when they go around the sun? Starts with an O. Orbit. So this was, I don't know, let's see, Mercury, Venus, here's Earth. Earth is going that way. Which one do you think goes the fastest around the sun? Which planet? Inner or outer? Think? Kind of makes sense, doesn't it? But you know what? It's that one. It's flying. I think 38 days it can go around. So 1 year on Mercury is like 38 days. The Earth is 365 days. I can't remember. Mars is 1.5 years for us. So if you were born on Mars, you'd have to start adjusting your time. And these are moving fast, but look, they got a bigger distance to travel. Bigger distance. I think this is Neptune or Uranus. And I think it's every 200 years is a year on it. It just takes, because it's so far away. But the sun is trying to pull them in. But they're never, ever going to fall in unless they do what, you think? What do they got to do before they get pulled in? I want to see if you get it. Run out of energy and do what? Stop. If Earth were to stop, it would instantly start speeding up toward the sun. And same thing for Neptune, Uranus, Mars, all of these. If they stop dead in their tracks, they're going to get pulled in. So kind of understand it. I'm going to show you what we understand as a picture of gravity, even though we don't understand it. I think where it came from and how it is. But I'm going to show you a picture. So check this out. Now remember, these are objects. Massive. Massive compared to us. If you weigh 100 pounds on Earth, so I weigh roughly 200. Look at this. If we could stand on the sun, it's so big that it's pulling us at, we're going to weigh 2,707 pounds. Could you stand there? If the pull was that strong, what would happen to your legs? Try to put a car on your head. What's going to happen to your legs? They're going to go. You're going to give. Mercury, you'd weigh 37 pounds. Venus, 90 pounds. Earth's twin, 90 pounds. The moon, 16 pounds. I remember in Earth Science that the astronauts, when they were training them how to walk on the moon, they were underwater. And the trick is, if you fall, how do you get back up? And how do you run? Or how you walk? And you couldn't walk like this. You had to like do a hop. And that's all because the moon doesn't have the strong gravity. Mars, 37, really close. Really close. Phobos is a moon of Mars. Look at this. You weigh 600th of a pound. So you could technically probably go and take off like Superman. Jupiter, you'd weigh 236 pounds. The moon, that's Ganymede, Europa, Io, these are moons of Jupiter, Callisto. Saturn, not quite as big. Titan is a moon of Saturn. If you stood on Uranus, 88. 112. Neptune, be pretty close. Be pretty close. And then Pluto. They knocked Pluto out of the planet. It's now called a planetoid. So we have 8 that we know of, not 9. Okay? And then Earth's gravity is it's 9.8 meters. So remember, it's that pull, 9.8 meters a second. All right? Last thing. Any questions on gravity? I'm sure I'm forgetting something. Now, projectile motion. My son was doing a science fair project and he wanted to know what was the best angle to shoot a, not airsoft. What are the guns called that shoot the foam arrows, the darts? Nerf. He had a Nerf hand pistol and he wanted to know. So we set it up and we shot at these different angles and we would measure how far it would go. Well, one thing he noticed, he says, it's always making like a half a circle, Dad. And it would always look like this. But if your angle was too far, it wouldn't go very far, but you'd still have this like circle, half a circle. That's what they call projectile motion. So on Earth, you see it, they're playing football, they throw it, man, it goes up, 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 all gravity takes over and then it lands. Kick the ball, same thing. Now, remember I told you about the vomit comet? That plane is flying like this, jet plane as fast as it can go, and then it starts to take that projectile motion back down to Earth. And it's from this point, remember, to about here where you don't have gravity. But we know that the curved path, and from what we found out, we did it multiple times, a 45-degree angle. That's the best angle no matter what you're shooting, gun, artillery, a rocket, 45-degree angle. That's going to give you the farthest distance that you can go, no matter what. And so if I were you, I would be drawing is this shape right here. This is that where it's overcomes gravity, and all of a sudden gravity takes over and pulls it down. And so there's a relationship there that you just can't go. So forward velocity and downward pull. So the faster it goes, the downward pull always is going to give you that shape. That's called projectile motion. And again, 45 degrees is the maximum. So remember, we're in that physics part of the course. So we got to know projectile motion. Okay. Any questions? Okay. Now, I'm going to stop.